Hello everyone and welcome to our Senior Design Project Overview. Our team is SP21-3, but you can call us Digital Guide Dog. The goal of our project is to create a cane attachment that performs object avoidance and detection to guide those who have vision impairments. The motivation for our project stems from the fact that only about 8% of people with vision impairments use a white cane, while the rest choose some other form of guiding assistance, such as a guide dog. This is most likely due to the limitations of the standard white cane. We hope to change that. Initially, our handle design was created in AutoCAD. At the top is the base of the handle. The base contains grooves, easily allowing the user to grip the handle. These grooves also serve to store the vibration motors, which notifies the user when they are approaching an object. There are holes at the top of the base to store push buttons. These buttons allow the user to interact with the handle and the underlying code. A white cane can easily slide into the base of the handle, then be tightened down to secure it. In the center of the handle is a platform which holds the Raspberry Pi and the prototype board. The end of the long shaft holds the depth camera. This places it in proper position to efficiently detect objects. And this is what the project looks like with everything 3D printed and attached.
Our hardware components include a Raspberry Pi 4 Model B board with 4 GB of RAM, an Intel RealSense depth camera, 3 vibration motors, and a push button. The Raspberry Pi acts as our main compute resource, which handles all of the processing of image and depth information provided by the camera. The vibration motors are used to provide depth information feedback to the user based on the distance to closest objects. The push button allows for a user to determine whether they would like a list of nearby objects to be shared with them.
Because our project was more software based, there were a lot of software packages needed. The major ones are listed below in this table. Due to the social distancing measures taking place this year, our team had to remotely work on the software for our project. To do this, we used a program called MOBA Xterm to remotely log into the Raspberry Pi. All of our code is saved using Git's version control software, and the repository is saved on GitHub. This allows us to keep track of all changes, and it makes it very easy to have multiple teammates work on the code. As you can see, our main driver script simply sits in a while loop and constantly gives the user vibration motor feedback. Using the GPIO0 library, we are able to continuously scan for a button press and then proceed to the object detection to give a user valuable information. By far, the largest part of the project was the object detection and analysis. In order for our project to be successful, inference speed was more important than high accuracy. This led us to using a single-shot detector called MobileNet SSD. Here's an example of what the user will hear if multiple objects are detected.
The bed is 1.5 meters away and is to the center direction. The person is 2.3 meters away and is to the left direction.
In the Pi terminal, the green text is what is read off to the user. If no objects are found and/or pass our filtering system, the red text is read off to the user.
The chairs in front of me to the left. TV is also further away to the left. The couch was 1.9 meters away.
Thank you so much for watching. We hope you enjoyed our project.